Okay, well, let's do a little bit of a video on this one single one. This one and the next one are very obnoxious, and it doesn't seem like they are when you look at it. It's like in the figure to the right, prove that the sum of the angles marked by the arrows is equal to 900. And it's like you need to write several labels on it to keep track of stuff. It's very true. You're going to end up having to write 12 different labels. This one, if you're looking at this and you're thinking it's easy, it's not. It's actually it is easy, but it's not easy to figure out where to start and what to do. So don't freak out if that's what you're feeling right there, but also don't underestimate it. This one, bear with me when we talk about this. I'm just gonna go through the alphabet, and it turns out the teacher edition also does. So I might not label it the exact same way they do, but it doesn't really matter. J, K, and as the teacher edition does, I'm not going to label this with an L. L is too hard to kind of differentiate between that and the letter and the number 1. So I'm going to skip to M as well. We could have used X, Y, Z, W, and then done stuff, but it doesn't matter. I'm just labeling all my angles because I know I'm going to need them. And one thing that I notice is that while they're asking for this part of the angle, one thing I do know, because the only way I can do it is to add up all of the angles around a circle. So in that case, what I'm highlighting here is I'm going to add up all the angles around a circle because I know a fact about that. And I'm going to do this for each individual one. I'm going to add up all the angles around a point because that's going to be super helpful. So that first one, A plus B plus C plus D is equal to 360. This is angles at a point. Angles at a point sum to 360 degrees. It's 360 degrees to go all the way around a circle. So that's why all the angles at a point sum to that. And I'm going to do that 3 times because we're going to need all of them. E, F, G, H. So I'm going to put plus signs in between them, even if it looks gross. And I wrote them really close together on accident, so just kind of, I would say just forgive that, but I know that I want this to look nice, so let's kind of move this to the side. I imagine, what if I had a teacher reading this, and how they'd be upset if it was super messy. And I'm going to put ditto marks on this one. Normally we don't do this, but like if you're doing this for a college professor, you could probably get away with that. If you're doing this for the leap, don't do that. I plus J plus K plus M equals 360. So all 3 of these add up to be 360. Now, I could do a lot of things. I could do a substitution thing. There's a lot of different methods for this. I don't agree with one of the steps that the teacher edition does. And I worked this out on my own, too, and I did it the way that I like to do it. So kind of, you're going to have to understand. So in this case right here, what we're going to do is, since the left side of an equation is the same thing as the right side, this is a thing from Algebra 1 when you dealt with systems. Since the left side of an equation is the same thing as the right side, if you add the left side to another equation and the right side to the right side of that same equation, you are effectively adding the same thing to both sides. I always did it, and nobody told me that, and I was like, why? That doesn't even make sense. But when you add the left side of an equation to another equation, and the right side to that same equation, then what you end up doing is you're still adding the same thing because an equation says that both sides are the same thing. So we didn't break any of our rules. But if I add all 3 of these left sides together, and I can keep doing this, so if I use the addition property of equality, this is what I'm doing, and what they're doing, and what most people do in this case is they add these 3 equations together, left sides together, to get the alphabet. All added together with little plus signs in between them. And again, the whole reasoning for this is that we can do this because equality says we can do this. And the right sides become 360 plus 360 plus 360 is 1080. Now, this is where I have a lot of that. I have that all of the angles, all three of these angles added up is 1080. This is a sick 1080 you did there. But I don't want that. I want everything on the outside of this little triangle that we made by intersecting three lines. So I need to get rid of this, the angles of this inner triangle. And the only way I know how to do is subtraction. There is another way, and I'm going to show you a different way as well. But I'm going to do it the easier way first. So I'm going to remember that the measures of the angle of a triangle, the measures of the angles of a triangle add up to be 180. And then what I'm going to do, and this is sum of angles, I'm going to abbreviate of triangle equal 180. That's just the property we're using. What I'm going to do is I'm going to take this first equation and I'm going to subtract the second equation by the same reason that I was able to add these together. I can add the left sides of an equation to the left side and the right side to the right side, and that will maintain equality because they're the same thing that's getting added. Or I can make a new equation by subtracting it. So that's what I'm going to do. I'm going to subtract this left side from the left side of that first equation, the left side of this one from the left side of that first equation. And I'm going to use it as it's still the addition property. Sometimes they call it the subtraction property. But it's really just adding the inverse, adding the negative of it. So prop of equalities. So when I subtract them, D is going to get subtracted. So I won't have a D in there. So this D is going to go away because when I subtract this left side, it's going to be D minus D, so this will go away. And it's going to be H minus H, so that will go away. And it's going to be M minus M, so that will go away. So I won't have D, H, or M, which is what I want. So A plus B plus C plus E plus F. So be careful not to write the stuff that's subtracted off. And on the right side, 1080 minus 180 is 900. Now we got to remember, those are the angles marked. CBA, GFE, and KJI. Those are all three things represented, and they all add up to be 900. Now this one could be a little bit more obnoxious in a lot of ways. So what they did, if you're ever wondering what they did, they used the substitution property. They used the substitution property. So they grouped up D, H, and M and realized that that is those added together are equal 180. And so instead of writing D plus H plus M, they just wrote 180. That's called the substitution property. That is also perfectly valid. You don't have to just substitute one thing. You can substitute multiple things at a time as long as you're replacing the stuff that is equal to something else with what it's equal to. And then they had a plus 180. So in this case right here, it's the substitution property. I'm just going to write it as sub-property. Equals 1080, and then they subtract 180 from both sides using the subtraction property. So they still use that. So I feel like one line shorter if you just subtract instead of trying to substitute, but it doesn't really matter in the long run. Let me see if I can get rid of all this, but actually I don't need to do this on the thing. So that was that one. The next one is also kind of is pretty wonky. I don't even know if we're going to go over it that much. I'm probably going to make a video, but I don't feel like it's super necessary. It goes over a lot of the same properties, just so much just together, and it's pretty convoluted. So I'll give that thought on if I have time, because I still want to prepare a thing for constructions for y'all. So I will let y'all go for right now.